Alright, so in the last video we have seen an example if the OPC UA server exists inside your controller. So yeah, we have seen the example of Siemens S7-1200, and I hope you have seen the videos of OPC UA server in PLC Next. So we know that this PLC has server inside it. Now what about the PLCs which has no server inside it? For example, let's take an example of, let's say, Delta PLC, and most of you, I hope, has a Delta PLC with you, and you know that there is no OPC UA server inside. Or a PLC like Siemens Logo PLC, which has no server inside, but they're also reading the value from factory I/O, or they have a real-time data, or they have some sensors and actuator. What to do with that? How can I link my clients like Node-RED, or UA Expert, or Visual Component, or Automation Studio, whatever client? How do I link it with these devices? What do we need? So these days in the market you have IIoT device which has several communication with many different PLCs, and they have their built-in OPC UA server. So in this case you will connect your IIoT device to your PLC. Now this IIoT device has several ways to communicate with PLC. One example is with Delta PLC, it can use Modbus, or it has some specified plugin inside in which you don't have to do any programming, just specify which PLC you want and it will connect. Another connection is like S7 connection, which can be done using, which is used for Siemens PLC most prominently. So these Modbus and S7 connections will be made with IIoT device. And further, this IIoT device can make OPC UA connection with the client, because this will read the values from this PLC and it will make a server inside it. So OPC UA server will be in the device, in this device, not in this device. This device has no server inside, but these can share the values to the server, and then the server will make this an OPC UA server inside it. Another interesting example is if you don't have this device, but if you have a Siemens PLC, in this case. So for example, if you have Siemens PLC here, and if you have seen my Modbus lessons, the Siemens PLC can read from Delta PLC via Modbus. This PLC can also read from Logo PLC via S7 connection. And this Siemens PLC you have seen in the last example has OPC UA inside. So the tags which you read in the PLC, just migrate those tags in the server, which I've shown you in the last example, server interface. In this case, your Siemens PLC has an OPC server inside. It can be a kind of IIoT device for you. This is a very good example. Maybe you should try, if you have Siemens PLC and some other PLCs which does not support OPC UA, talk to them via Modbus and then create your OPC UA server inside the PLC and then distribute the value. But in this example, I will show you an IIoT device which is capable of linking to many PLCs. So let me show you first this IIoT device, and then I will show you the steps behind it. So this IIoT device is from WineTech, it's a company, and if I show you the interface, in this IIoT device you have a setting button, OPC UA, MQTT, and download. So if I show you the settings, here I have added my Logo PLC and my Delta PLC. And if I have to show you which other PLC it supports, so I click on New Device and Server, and here I can see a lot of PLCs from different companies which it supports. So you can see that IIoT device can read from all these PLCs, and it can read from multiple PLCs. In this case, I'm reading from 2 PLCs. And the connection between this IIoT device and this PLC is just normal Ethernet connection. There is no special cable, no special wires. Just plug it, give some power, 24 volts, and connect this connection via Ethernet switch or directly to your PLC. If you want to know more about this IIoT device, I have made some web series for this IIoT device from WineTech. You can watch it, and I've explained how this OPC UA works, the different steps of connection. I will mention these videos in this course as well, and you can read that and you can watch it. So the important thing to see here is if I show you this Logo PLC has an Ethernet port. This is important how I plug it to this PLC. If your PLC doesn't have Ethernet, it doesn't need to have an Ethernet, because this IIoT device also supports this COM or serial port communication. If you have a Siemens PLC which doesn't have Ethernet, for example, it could be 14SS. So instead of here, what I'm using is 12SA. So maybe I will write it here. It's an important information. Here I'm using 12SA PLC. If you have 14SS PLC, for example, this can also talk to the IoT device. In this case, it could be RS-232. It can also be 485. It depends which communication protocol your IoT device supports. So this supports RS-232 as well. It supports Modbus as well. So doesn't need to be your PLC or any other hardware device need not to be Ethernet always. It depends on what your IoT device supports. So before you decide if you want to use IoT device, you have to check if this device supports the communication which your hardware has. So the PLC which is already in your industry, in your factory, in your machine, and if you want to visualize it in the dashboard or the different OPC UA clients, you need to put this device, IoT device, inside it and make sure they talk to each other. So once you have the value here, you have a server, and now you can take the values out. So now I will show you one example. So first I will show you how the parameters are defined in this server. So here, if I open this logo, here you can, I've mentioned this PLC's logo. It has Ethernet and it has this IP address, and this is the port number. So this is a unique IP address of my PLC, and that's the port number that I have to mention here. And there are some values here which I need to mention, because this connection is an S7 connection between IIoT device and Siemens, and there's a document of these connections. So these settings which I have mentioned here has some meaning, and I will mention that in the document in this course of videos. And here I have just selected the model number, and these settings are specifically for IoT device and the Siemens PLC. Okay. In case of Delta, it's a bit easy. So in case of Delta, if I open it up, it also shows here the IP address and the port number. And in the setting, there's nothing, just the IP address and port number. So for Delta, it's much more easy. So these are the two settings I put in my IIoT device for defining the device which is reading from the physical environment. And next is OPC UA. So here I define the tags. So for example, for logo PLC, I have defined 5 tags. One is M1, M2, Q1, Q2, Q3. So if I open this M1, you have to just mention the address M1. It should be readable and writable. Similarly, M2, and similarly Q1, Q2, Q3. In case of Delta, it's also easy. It's defining D0, readable, writable, and this is a word. Similarly, M0, which is a bit, M0, quite easy. So addressing is quite easy in this IoT device here as well. So once you do that, just download this in your device. And once you download it, you can open your server settings in the web interface. This I've already explained in the series of videos on this IoT device. So this is my OPC, this is the link of my IIoT device. And here, if you notice the OPC UA server inside this IoT device, this is the same IP address and the port 4840 and the name G01. So this is the IP, this is the URL of OPC UA server. Like I have this for my Siemens PLC when I talked about the OPC UA server inside the Siemens. This is the OPC UA server in the IIoT device, so it has the same URL. And after downloading, you have to make sure, if you're not using username and password access, if you're using anonymous access, you have to make sure this right is enabled. And if I show you in my IIoT device, after downloading this logic, if I go to edit nodes, I can see the tags in my web display. So these are the tags inside the IIoT device. This red color doesn't mean it has an error, it's just a normal display value. Okay. Now let's go to the client. So we were here. So next step I will show you in the client how I can read from the IIoT device. It's the same step. So I just need to know this address, and I will copy this, open my client. So you can see that this is the last two clients. This was a Siemens PLC, this was a simulation. I will add one more. Double click to add server, paste the link, click OK. And this must be here. Double click, open the wine tag, and I will go to none. So now you can see that the server is here. And here I have two folders which I need. One is Delta, one is Siemens. So Delta tags, Siemens, and Siemens tag. And interesting thing is, if I show you this one, it says NS2, namespace index is 2. Also same for Siemens, because this is coming from one server which was IIoT device. Okay, and I told you in the beginning, namespace index is unique. If I show you for Siemens, for example, conveyor, here the namespace index is 4. And this is integer identifier because this has some values inside. So for example, maximum limit is also NS4. And here you can notice this is I23. Now this is numeric identifier. In case of WineTech, we have, let me see, we have numeric, or in case of IoT device, we have a string identifier. So here is the difference. Sometimes you have identifier which is validated by a string. Sometimes you have identifier in case of Siemens, which is coming as integer. Now the difference is, if you have integer identifier, it's easy to read and write. And for string, it takes more time. That's what I get to know about it. So coming back to IoT device, this is the D0, D10, M0, M1, Y0, Y1. So for explanation, what I did, let's go to the presentation. I connected this Delta PLC and my Siemens PLC with Factory IO via OPC UA. So first, these values are coming to this device. The tags are going to this IoT device. IoT device defined a server. And what I did, because my software is capable of doing that, I will write it here. I have linked this device via OPC UA with my Factory IO. And Factory IO in this case is my OPC UA client. This is also OPC UA client, and that's also a client. And this is reading and writing the value. So I'll show you this first. So go back to Factory IO. So I made some conveyors, some push buttons and potentiometer. And if I go to my drivers, I have selected OPC client DAUA, go to configuration. So here I did the same thing which I did for UA Expert. I just pasted the OPC URL here, clicked on browse servers, and then you will find a server here. And then you click on browse. And here I have mentioned IIoT because when you talk to a server, it has a lot of tags inside. Now if you see here, it has not only these tags. If you go to statistics, there are some more tags here. And if I go to server has its own tags. Something is going on here. I don't need to read all this information. So what I did here in Factory IO, I put a filter IIoT. And if you notice, in every tag I defined in IoT device, I put the name IIoT, so that I can filter out the tags which I need to read. That was the only reason. If I just write logo, I will read the logo tags. If I write delta, if I write delta here, I will read only the delta tags. So I put IIoT because I use this name in all the tags, and this should be a unique name. So this is just to filter out unwanted tags. So when I go back here, you can see IIoT logo M1, M2, Q1, Q2, Q3. So you can see that M1 is also to read and write. But M1 I used only to read, because if I show you the logic, sorry if I'm too fast. Logo is for logo PLC. This is for Delta PLC. Now, so in Factory IO, I'm using two PLCs to control the conveyor. This is not possible otherwise. Otherwise, if you see here, you can only select one PLC. But because I'm using OPC UA, and because I'm using OPC UA in the IIoT device, and because IIoT device can read from different PLCs, so I have two PLCs writing the value to IIoT server, and then it is showing the value to Factory IO. So in the end, Factory IO is reading from two PLCs. So here, that's why you see IIoT logo, IIoT delta. And I have made a simple logic in the delta, in which M0 is latching Y0, M1 is unlatching Y0, and Y0 is moving a value from D0 to D10, and when Y0 is off, this value is 0. Okay, so basically D0 is my conveyor speed. Similarly, I have this same logic in logo PLC. This M1 is having a signal going to RS flip-flop, which will latch Q1, and M2 will unlatch this Q1. This is a NOT gate. And Q1 is further giving signal to Q3, and this is a NOT gate giving signal to Q2. So it's just for displaying the lights. So these are two basic logics in my PLC which are running. And then I have my factory IO, which is reading from IIoT device. So basically when I go here, and here you can see the red light is on when I go and press this button. So this factory IO as a client write the value to the server. So it basically write the value to this server, and the server writes the value further to my logo PLC, which is here. So here you can see that Q1 is set, and when I press another button, wait, I need to put this window here and this window here. Now it's good. So this is running, and wait a second. Now I can press stop. This will trigger this one, and it will unlatch Q1 and latch Q2, which is my red light. Again, I can go to start, and I can go to stop. So this is a client talking to IoT device, and this is IoT devices talking to my logo PLC. Let's see the same example with Delta PLC. So for Delta PLC, I have the logic here. I bring it here and maybe show you like this. So again, this is red is on because of Y1. So I will latch it, and now conveyor is not running because the speed is 0. It's an analog conveyor, so I will give some speed, and you can see now the conveyor is running. This is in floating. This is showing in numerical, but it's a floating value. So the value which is inside the conveyor is basically 3.5. And this you can also see if I show you the monitor tag, monitor window, new, okay, show me D0, show me D10. So check the floating value, 3.4. So here it's the round of value, and I can increase it. 5.6, 5.7. So this is the value which I am reading and writing to my PLC. So this is one OPC UA client. I forgot to put in the presentation, but I wrote it here. Another OPC UA client is this one. So this is also reading the value. So if I show you D0, you can see the values here, 3.35. So this value is coming to this client, which is in the end writing to the PLC. So you can see this value here, and I can change the value from here. So you can see the values updated in every client which is connected to the server. That's what I wanted to show you. So in this example, what we have seen, this is just the example to understand how the client and server interact without OPC UA in the controller or with OPC UA in the controller. So in this example, we have seen how IIoT device can be used to read-write the values from the controllers. Okay. And further about Node-RED, we will do detailed lesson how Node-RED can read from IoT device. Okay. If you have doubts on how this IoT device is configured, please watch the lessons which I've mentioned about this IoT device in my course. Okay. So this one topic is split into different topics. And now comes the fourth case, in which if you don't even have an IoT device, you just have a PLC, or for example, Delta 14SS or 12SA, and you have nothing. You have no servers, no IoT device. Still you want to learn OPC UA, how you can do that. We'll see in the next lesson. See you.